In this lecture, we're going to discuss the second lecture of acids, and we're going to talk about carboxylic acids this time. And acids react with bases to produce salt plus water. The only difference between the previous reaction and this reaction is that instead of hydrogen gas being produced, you have water being produced, and the salt is produced in exactly the same way. So acids are going to react with bases, and remember, bases are mostly metal oxides, metal hydroxides, and ammonium hydroxide. These are bases. They accept H+1 ions, but they're not limited to this. But for O levels, this would be sufficient. So bases are metal oxides, metal hydroxides, and ammonium hydroxide. So I'm going to start off with a simple acid. Let's talk about HCl. And remember, the reaction, the salt is going to be produced in exactly the same way. Let's think of a base, a metal hydroxide. I'm going to take a group 2 hydroxide. Let's say magnesium hydroxide. Magnesium is 2 plus and hydroxide is 1 minus, so it's going to be MgOH2, and the salt is going to be produced in exactly the same way. But I'm going to write down water first, because water is always going to be produced. It's going to be one of your products. So the salt that would be produced is we have HCl. The salt would be produced in exactly the same way. Get rid of the H and put a metal or an ammonium ion in its place. In our case, the metal that we have is magnesium hydroxide. So I'm going to get rid of that H, and I'm going to put magnesium in its place. So it's going to become MgCl, and MCl is -1, Mg is 2 plus, so it's going to become MgCl2. So that would be my salt. So instead of this H, I've put magnesium in its place, and that's how a salt is produced. So the salt that would be produced in this reaction is going to be MgCl2, and we need to balance this equation. So there are 2 Cls over here, there should be 2 HCls. Over here, there are 4 hydrogens in total, so there should be 2 water molecules. Now it's a balanced equation. So this is how your reaction is going to be carried out for a normal acid. The only thing is that water would be your product. Now we're going to move to carboxylic acid, and let's start with the simplest carboxylic acid. Let's talk about ethanoic acid. So it has 2 carbon atoms. Eth means 2 carbon atoms, and since it's a carboxylic acid, it's going to have a C double bond O and OH, and carbon is supposed to make 4 bonds, so I'm going to make all the bonds with hydrogen. So this is ethanoic acid. The other way, the compressed form of writing ethanoic acid is that you have C and 3 hydrogens, so that's CH3. Then I have C, 2 O's and 1 H, so that's COO and H. I could also write it as CO2H. So that's my ethanoic acid, and I'm going to the first thing to know about carboxylic acids that we've discussed previously as well, it's this hydrogen over here that gets replaced. Nothing happens to the other hydrogens. It's the carboxylic acid group, the functional group, that loses the hydrogen. So that's my ethanoic acid. I'm going to react it with a base. Let's say I'm going to react it with any OH, sodium hydroxide. It's in group 1. So I'm going to write down 2 equations, one with the structural formula, one with in the compressed notation. So the salt that would be produced is going to be, everything is going to be exactly the same. You're going to replace the H in the acid. So I'm going to replace this H over here with the metal ion, which in this case is sodium ion. So I'm going to replace that H with sodium ion. So this is my salt. It's called sodium ethanoate. Since it was an ethanoic acid, so the salt would be called an ethanoate. So it's sodium ethanoate. Sodium is the metal. And the last thing that we are forgetting, the most essential thing, that is that a water molecule is going to be produced. It's going to be a product in this reaction. So this is your balanced equation. I'm going to write down that in compressed notation as well. So it's CH3, COO -1. I got rid of the H at the end of the carboxylic acid functional group, and I'm going to replace it with sodium ions And the other thing is that a water molecule is going to be one of the products. So that's your reaction. That's how a carboxylic acid reacts with a base. The only difference is the water would be a product. Now let's do another reaction, and this time I'm going to react propanoic acid. I'm going to react propanoic acid with let's say calcium hydroxide. So it's propanoic acid with calcium hydroxide. Now propanoic acid has 3 carbon atoms, so they're going to be 3 carbon atoms, and it's a carboxylic acid, so it's going to have a double bond O and OH group, and the rest of the bonds would be completed using hydrogen, so there should be 3 hydrogens next to this carbon atom. So that's your propanoic acid. The other way of writing, the compressed form of writing propanoic acid is you have CH3, then you have this CH2, and at the end you have COOH. So that's propanoic acid. I'm going to react it with calcium hydroxide. Now calcium hydroxide, Ca is in group 2. Hydroxide has a -1 charge, so it's going to be CaOH2. So I'm reacting it with calcium hydroxide. And the product that would be formed is, you're going to get rid of the H at the end and replace that the carboxylic acid group H. So you're going to replace that H with calcium. So I'm going to draw propanoic acid first, and so that's my propanoic acid. These are all hydrogen atoms. I've gotten rid of the H at the end, and that would be my salt that would be produced, and I'm going to put Ca2 plus in its place. Now remember, CH2 plus and this ion has a -1 charge, so remember the crisscross method for writing formulas. So there should be 2 of these to balance out the charges, and the other thing that would be produced next to it is going to be a water molecule. So water would be produced. So you'll have a water molecule being produced. Now I'm going to write a compressed version of the same thing. Now in the compressed version, I'm going to write this down. It's CH3, then you have CH2, then you have COO -1, and there would be 2 of these ions, and there's going to be a Ca2 plus next to it, and plus a water molecule will be produced. You need to balance this equation, so there should be 2, because you had 2 ions, so there should be 2 propanoic acids, and there should be 2 water molecules because you have 2 OH ions over here. Now the equation looks balanced. So that's your salt that would be produced. So remember, you need to balance out the charges if the charges are unequal, and remember, it's the H at the end that is always replaced by a metal or an ammonium ion. The name of this salt is going to be, because it's made from propanoic acid, so it's going to be propanoate, and calcium is the metal, so it's going to be calcium propanoate, and that is your salt in this case. And let's do one example relating to a more slightly confusing example that examiners will try to put you off course. They're going to give you a complicated, let's say we have a complicated acid. So I have this acid, which is, the naming is not important for O levels. So this is my acid, and if you look at the acid carefully, you'll see that it has 2 carboxylic acid functional groups. What that would mean is, there's a carboxylic acid functional group over here, and there's a carboxylic acid functional group on the other side as well. So what that would mean is that 2 of the hydrogens are going to get replaced when it reacts. So these 2 hydrogens, the carboxylic acid hydrogens, they're going to be lost when this acid reacts with a base. So let's think of a base. I'm going to take barium hydroxide. Barium is in group 2, so it's going to be barium hydroxide, BaOH2. the salt is going to be made in exactly the same manner. These two hydrogens are going to get replaced, and let me draw the molecule again. O minus 1. Now, and I have to draw the hydrogens. There are two hydrogens remaining over here. So the double bond is there just for confusing you. Mainly it's the carboxylic acid functional group that's going to react with the base. So all those two hydrogen ions are now lost. They're gone. And if you look carefully, the charge on this ion is going to be 2 minus. So it's going to be 2 minus because two of the hydrogens are lost. And barium has a charge of 2 plus, so that means that both those two hydrogen ions would be replaced by only one barium ion, because barium has a charge of 2 plus. So the charges are balanced now, and water molecule would be the other product that is going to be formed. So the only difference between in this question and the previous question was that instead of having a simple molecule, we have a molecule which has a double bond as well, which has two carboxylic acid functional groups. The rest of the question is exactly the same. Both these hydrogens in the carboxylic acid functional group are going to be lost. They're gone. And when they're gone, this oxygen would get a -1 charge. This oxygen would also get a -1 charge. And if you add up the charges, the entire ion, the entire molecule is going to get a 2 minus charge. So you just need one barium 2 plus to get rid of both the hydrogen ions. So the charges are now equal, and water molecule would be your other product, and we need to balance the equation. So since the two oxygens over here, it should be two water molecules on this side. So that sums up the case for a slightly complicated example of a base and a carboxylic acid reaction.